All right, welcome to the Explainer. Today, we're going to pull back the curtain on the hidden blueprints that shape the software we rely on every single day, from the apps on our phones to the huge systems that basically run our world. Let's talk about how we get from chaos to control by understanding software process models. So, to really get to the heart of this, we've got to start with one really big, fundamental question. I mean, it seems like it should be straightforward, right? You get an idea, you write some code, and boom, it works. Simple. But as you probably know, the reality is, well, it's way more complex than that. And honestly, this is the core problem the entire field of software engineering was basically invented to solve. And this quote really reframes the whole problem in a super interesting way. See, it's telling us that building software isn't just a logic puzzle. It's about capturing knowledge. The source material actually calls it a social learning process, which is a great way to put it. You're trying to take all these scattered, unspoken ideas from a bunch of different people and somehow turn them into one single working thing. And that right there is the danger. Because without some kind of plan, that whole social learning process can just dissolve into total chaos. We're talking confusion, missed deadlines, and a final product that nobody's happy with. So the big question is, how do you actually bring order to all that potential chaos? And that brings us to the solution. It's this idea of a software process. Think of it as the blueprint for the entire project. Yeah, it's exactly like a blueprint for building a house. It gives you a framework, right? A series of steps you can follow to guide the team from just a vague idea all the way to a high-quality finished product. It's all about bringing in stability and organization where, let's be honest, chaos would love to take over. Okay, so at the core of pretty much any process, you're going to find these 5 basic activities. You can think of them like universal building blocks. Doesn't matter what you're building, you've got to communicate, you've got to plan, model, build the thing, and then get it out there. These are just the non-negotiable steps to turn an idea into something real. But, and this is super important, how deep you go on each of these steps changes a lot, depending on how complex the project is. I mean, for a really simple app, communication might just be a quick phone call with the client. But for some huge, complex system, we're talking a whole series of formal meetings and super detailed user scenarios. The point is, the blueprint has to fit the building you're trying to construct. It's not one size fits all. So how did people first try to put these blueprints into practice? Well, let's look at the first big attempt to create a kind of universal model. These were called prescriptive models. And yeah, their whole goal was to bring order to that chaos we were talking about. And the granddaddy of them all is the waterfall model. This is the classic. It's that original straight-line blueprint. Just imagine, you're building a simple garden shed from a kit. You follow the instructions, step 1, then step 2, then step 3, and you never, ever go back. That's the whole idea behind Waterfall. And the flow is just as rigid as it sounds. You have to finish each phase completely, like 100% done, before you can even think about starting the next one. So you can't start planning until communication is totally wrapped up, and you can't write a single line of code until the entire model is signed off on. It really is a one-way street, from start to finish. Yeah, but as you can probably guess, this super rigid approach runs into some pretty big problems in the real world. For one, real projects are just messy. They almost never follow a perfect, clean, straight line. Plus, it's really hard for clients to know exactly what they want right at the very beginning. This model also creates what are called blocking states, where maybe the developers are just sitting around waiting for the designers to finish. And maybe the biggest problem? You don't see a working piece of software until the very, very end of the whole process. So, if the real world is so messy and unpredictable, how are you supposed to build a blueprint that can actually handle change? Well, that exact question led to a whole new generation of models that are way more flexible and adaptive. And it all comes down to this one question. This is what really sparked a revolution in how we think about building software. It led to something called evolutionary models. And their whole reason for being is to embrace change, to allow for discovery, and to build in feedback right from the start. A perfect example of this is the prototyping model. Instead of trying to plan everything perfectly up front, the idea is you just build a quick and dirty working model, a prototype. Think about it like this. It's like building a cardboard mock-up of the kitchen for your dream home. It lets the client actually see it, touch it, feel it, and give you real feedback. That way, you can refine the requirements before you go and spend a ton of money on the final build. Then for the really big, super complex projects, you have something like the spiral model. It's kind of a hybrid. It's designed to build software in these repeating cycles, or spirals. So with each loop of the spiral, the team does a little planning, they analyze the biggest risks, they build a new piece of the product, and they get feedback. This way, you're getting closer and closer to the final product with each turn, all while managing risks every step of the way. So, where does all this leave us today? Well, today, developers don't just have one or two blueprints, they have a whole toolbox full of specialized models to choose from. And what you see here is just a tiny peek into that toolbox. You've got things like component-based development, which is kind of like building with pre-made Lego bricks to make things go faster. Then you have formal methods, which use some seriously heavy-duty math to actually prove a system is safe, for things where failure is not an option, like flight control software. The main takeaway here is that the modern toolbox is huge, and it gives teams the power to pick exactly the right tool for the job. Which, of course, leads us to the final and most critical question, right? With all of these different options, how in the world do you pick the right one? So, how do you make that choice? Well, it really all boils down to the nature of the project itself. If your requirements are totally locked in, crystal clear, and you know they're not going to change, then hey, maybe this simple waterfall model is actually perfect. But if the requirements are kind of foggy and unclear, prototyping is your best friend for finding clarity. And if you're tackling some massive, high-risk system, the spiral model gives you that control and risk management you absolutely need. So you see, in the end, it's not about finding some single best process that works for everything. It's about the team really understanding the problem they're trying to solve, knowing the people they're building it for, and being honest about the risks. And then they can go to that toolbox and pick the blueprint that makes the most sense for that very specific job. And that kind of leaves us with one final thought to chew on. Is great software the result of a perfect, rigid plan, or does it come from perfectly embracing the inevitable chaos? The journey of making software is really just a constant balancing act. It's a tug of war between structure and flexibility, between having a plan and being ready to adapt. And maybe finding that perfect balance, well, maybe that's the real art of building something great.